Hello everyone. In this video, we are actually going to talk about an introduction to the motion in a straight line, rectilinear motion, then reference point and frame of reference. In our daily life, we can see moving bicycles, running trains, walking people, leaves falling from trees, and water flowing down a dam, etc. In all these examples, the objects are in motion, no? That is, in the case of moving bicycles, the bicycle is the object and it is in motion because moving bicycle. For leaves falling from trees, the leaves are the objects and they are falling from the trees means what? Leaves are in motion. Okay, so actually, what is this motion? You have studied about motion in the 9th standard. Motion is the change in position of an object with time. In this chapter, as the name of the chapter indicates, we are going to discuss about motion of objects along a straight line. The straight line motion, it is also called as rectilinear motion. In our discussions, we shall treat the objects in motion as point objects. What is a point object? An object can be treated as a point object when the size of the object is smaller than the size it moves in a reasonable duration of time. That is, an object can be treated as a point object when its dimensions are ignored or neglected while considering its motion. You have learned in 9th standard that motion is the change in position of an object with time. In order to specify the position of an object, we need to use a reference point and a set of axes. What is a reference point? Suppose a railway station is here and your house is somewhere here, that is 6 kilometers away from the railway station. So here you can locate your house by saying that your house is 6 kilometers east of the railway station. Because we usually use such directions, not this side east, then right side east, then this side west, then north, south, like that. So you can see here by using this directions, you can say that, or you can locate your house by saying that your house is 6 kilometers east of the railway station. Okay, that is, you can specify the position of any object. It can be the house or it can be anything else. You can specify the position of your house, here your house, by saying that your house is 6 kilometers east of the railway station. That is, here you have specified the location of your house with respect to the location of the railway station. So, railway station is the reference point in this example. Okay. So, in order to specify the position of an object, we need to use a reference point and a set of axes. It is convenient to use a rectangular coordinate system, that is the coordinate system which has three mutually perpendicular axes x, y and z. The point of intersection, you might have studied about this in mathematics. The point of intersection of these three axes x, y and z, this is the point of intersection of these three axes, that is this point. Okay, so this point of intersection of these three mutually perpendicular axes, that is actually called as origin, represented by O. Okay, represented by the letter O. This origin serves as a reference point. Clear? That is, we can specify the position of an object with respect to this origin. For example, let an ant moves on the surface. Let it starts from somewhere here Okay, let the ant starts moving from a particular point somewhere here on the surface, on the surface of this paper. Then it moves like this. Then after some time, it reaches somewhere here. Okay, now to specify the position of this ant started its motion from here, but after some time, it reached somewhere here. So now the ant is here. Now to specify the position of the ant, we can consider a rectangular coordinate system like this one. Okay, and here we need two axes because it is a motion on a plane, no? That is, it is a kind of two-dimensional motion. So we need only two axes to describe its position. I'm taking one as x-axis, another one as y-axis. Okay, so here I'm considering x and y axis and taking the starting point. This is a starting point of the motion of the ant. So I'm taking the starting point of the ant as the origin. Okay, then I'm considering the rectangular coordinate system here with the two axes. One is x, another one is y, and I'm taking the starting point of the ant as the origin. Okay, so let the ant be here at this point. I'm taking this point as A. Okay, let the ant is here at this point A after some time of its motion. Okay, ant started its motion from this point O. We have taken that as the origin of this coordinate system. Then after some time, the ant has reached somewhere here. I have taken that point as A. Okay, now let the x value corresponding to this point A be 2. Okay, x value corresponding to this point A be 2. And the y value corresponding to this point, let it be 4. Okay, that is the position of the ant is 2 units away from the origin along the x-axis and 4 units away from the origin along the y-axis. Okay, so the position coordinate of this ant will be what? Position coordinates usually represented like this, no, in mathematics. xy equal to what? X coordinate, that is 2, and y value 4. So the position coordinate of this ant is 2, 4. So this coordinate xy, that is here it is 2, 4 of the ant, describe the position of the ant with respect to this coordinate system. Okay, so in general, it is actually a motion on a plane. That is why we have taken only two axes x and y, two coordinates x and y. But in general, the motion can be in three-dimensional. Three-dimensional motions can be there. So in general, the coordinates x, y, z of an object describe the position of the object with respect to a rectangular coordinate system. Okay, I hope you understood the importance of the coordinate system in describing the position of an object. Now, to measure time, we position a clock in the coordinate system. The coordinate system along with a clock that constitutes a frame of reference. In simple words, we can define frame of reference as the coordinate system, any coordinate system with respect to which one can study the motion of the another object. You have learned in the 9th standard that rest and motion are relative. That is, an object at rest in one situation can be in motion in another situation. That is, for example, a person sitting in a moving bus is at rest with respect to his fellow passengers. But he is in motion with respect to a person standing on the road. Right. That is, description of an event depends on the frame of reference chosen for the description. For example, you just imagine that you are standing on the road And when you say that a car is moving on the road, you are describing the car with respect to a frame of reference attached to you or to the ground. But for the person sitting in the car is at rest because he also moves along with the car, no? That is, with respect to a frame of reference attached with a person sitting in the car is at rest. Okay, so description of an event that actually depends on the frame of reference chosen for the description. Alright. So in this video, we actually discussed about motion, rectilinear motion, then point objects, reference point and frame of reference. I hope you understood these concepts. Thank you.